the sum and differences of functions. So we're going to get into a simple activity to demonstrate that we can add and subtract functions. So we're going to consider three graphs below, f of x, g of x, and h of x, and we're going to complete the table. So when x is equal to negative 2, the value of f at negative 2, that is, I go wherever I take a look at my graph, f, which is that one, and when my x is negative 2, the value of my function is negative 3. And I can continue on for all values indicated in the table. And if I take a look at g of x, g is my function that I've just highlighted. The g of negative 2 looks like it's way up there. So when x is negative 2, the value of g is 6. And then I'm going to look at negative 1, 0, and so on, and complete my table. If you need to press pause, feel free. H. Now h is this function right here. At h negative 2, my y value is 3, h negative 1, my y value is 2, and so on. If you need to press pause, feel free. So there it is. And we have some strong indications that we're going to be adding or subtracting functions. But what do we notice about the relationship between the value of h of x and the corresponding values of f of x and g of x? I think it might be safe to say that h of x is equal to f of x plus g of x. And when I'm writing these down, I'm implying that it's the values of my y values. So the next question is determine the equations in slope-intercept form. Well, f of x, if I take a look at f of x has a slope of 1 and a y-intercept at negative 1. G of x is going to have a slope of negative 2 and a y-intercept of positive 2. So f of x is equal to x minus 1, where g of x is equal to negative 2x plus 1. And h of x just so happens to be negative x minus 1. So how are f of x, g of x, and h of x related? So in points, h of x was defined as f of x plus g of x, but when we take a look at the equations, it's probably best to define h of x as f of x plus g of x. That is, you could take the y values of the points and simply add them together. Or if you're taking a look at the set of instructions, you can simply add this set of instructions, f and g together, okay, or their equations, and you will get h of x. So this would be our first addition of functions. So we're able to combine functions in interesting and creative ways. For example, we can create a new function by adding two existing functions. So for example, if you graph f of x is equal to x squared and g of x is equal to negative 2x plus 1, then you could create a new function h of x simply by adding f of x and g of x. And what would be the formula for it? It would be x squared minus 2x plus 1. I mean, similarly, we can do this operation on functions for subtracting, dividing, multiplying, and other methods, including nesting functions, and we call this nesting of functions composition, which we will get to in a few days. So, the addition of functions. So, the addition of functions, h of x, is equal to f of x plus g of x. We can also write the addition of functions as the f plus g of x. I know these might look the same as you, but the first one means to me, we simply, if you want to get the addition of functions, you simply add the y's together of f and g respectively, and kaboom, you get h. Whereas equation number 2 really speaks to, well, you can just simply add the instructions of the two, or the expressions of the two functions f and g, and you'll get a sum of functions. Same argument can be made for difference of functions.